Hello, this video will help you understand how to find the sum of an infinite geometric series. The first thing that we need to understand is this difference between a divergent series and a convergent series. So if I have a series on the left here, 5, 10, 20, 40, 80, etc. A few things we can notice about that straight away. You should be able to identify that the first term of that series is not 10, it is 5. And then you should also be able to identify the common ratio. Remember, to find the ratio, you pick a term and you divide it by the previous term. So 10 divided by 5 is 2, and you could check that again. 80 divided by 40 is also 2. Now, if I were to plot this on a graph, you would notice that I've got a graph here. We've got n is the number of the term, so it'll be the graph of the first term, the second term, the third term, going along the x-axis, and the y-axis is the value of that term, so the actual numerical value of the first term, of the second term, of the third term. So I'm going to have the first term, and it is 5, so it will be approximately there. The second term is 10, and the third term is 20, the fourth term is 40, and then the fifth term is 80, which isn't actually going to make it on my graph. It's going to be up here somewhere. Okay. Now, what is happening with each of those progressive terms is they are getting larger and larger, or they are getting closer to infinity. All right. If I kept going to the 100th term, I would have a very, very large number. Now, it is diverging, that's why we call it divergent, it is diverging away from 0. Okay, so that behavior, the trend of that graph is going closer and closer to infinity. It's going away from 0. You could also have a series going towards negative infinity. Now, the way that we can tell if something is divergent or convergent is by looking at the common ratio r. If the absolute value is greater than 1, so it is a positive number that's larger than 1 or a negative number that's smaller than -1, then it means that that sequence or series is going to be divergent. Now, the formula today that we are looking at is going to be this one here, S infinity equals T1 over 1 minus R. But you'll see that there's a condition on this one, and it says the absolute value of R must be less than 1. Now, that means that this formula we are dealing with today, it's not going to work for divergent series. We are only looking at finding the sum of an infinite convergent series. Okay, if you think about adding up all of the terms here on the left to an infinite number of terms, then you would have infinity, okay, because you'd be adding larger and larger and larger numbers together. So that's not very interesting. That's pretty obvious, actually. So what we're trying to figure out today is, what if it's a convergent series? Instead of getting progressively further away from 0, what if each term gets closer and closer to 0? So for example, we've got -40 as the first term, and then -20 as the next term, -10, -5, -5 on 2, etc. So if we were to map the trend in that behavior, it would be getting closer and closer to 0 as we progress along the series. So what's actually happening here is we have an absolute value of the ratio r, which is less than 1. All right, if you're still not too confident with that absolute value notation, all that means is that the value of r is between -1 and +1. Okay, so if we have that condition met, then we are able to find the sum of the infinite number of terms of that series. Okay, because you can think about it, each one of those terms is going to be getting smaller and smaller and smaller and smaller and smaller and smaller and smaller until you're almost adding nothing. Okay, so eventually it is going to converge towards 0. It tends towards 0. Okay, there's another one here that's showing we have got T1 is 40 and we have got R equals, okay, what's happening here? You can see that it starts at 40 and then it goes to -20, then 10, then -5. So firstly, we know that R has to be negative. The way I can tell that is because it's jumping. Each term, alternate term, is jumping between a negative, a positive, a negative, a positive. So it's a negative R firstly, and then we have to figure out, well, what are we actually multiplying by? It looks like we're dividing by 2, which we are, so that means we are multiplying by a half. So r is negative a half there. What this would look like on a graph is we would have 40 as our first term and negative 20 as our second term, and then we'd pop back up to 10 and we'd pop back down to negative 5 and then negative 5 on 2. Now you can still see, even though I'm oscillating, which means jumping up and down, even though I'm oscillating on either side of the x-axis, you can still see that each term is getting closer and closer and closer to 0. So that one is still a convergent series, and it does meet our criteria, which is that r is between negative 1 and positive 1. Alright, so hopefully you've got a little bit of understanding of what convergent versus divergent means. And now once we have that information under our, once we have that understanding, we can use this formula here. All right, this one has come straight from your formula sheet in the geometric sequence section, and it says this: S infinity. Remember that sometimes in the past we've seen that as Sn. So this is, instead of a specific number of terms, we're looking at the sum of the first infinite number of terms. Okay, so that's the sum of the infinite number of terms equals T1, which is the first term, divided by 1 minus r, which is that common ratio. And there is that condition there, which is that the absolute value of r has to be less than 1. And in other words, that just means the series is convergent. Okay, so let's have a look at an example. It says calculate 100 plus 50 plus 25 plus 12.5, etc. Now, that is looking to me like a geometric series. How do I know that? Because each term is being multiplied by a common ratio of a half. So that's good. And we can tell that it's going to be a convergent series because the absolute value of r is 1/2, which is less than 1. So we're meeting a lot of our criteria now, so we're ready to go and use this formula. We have S infinity equals T1, right, which is 100, divided by 1 minus a half. Right, so what that is going to look like is 100 divided by a half. Okay, if you're dividing fractions, you should really be able to do this in your head. So what this, remember this line here just means divide. So it's going to be 100 divided by a half. And we do keep, change, flip. So you keep the first one, change the divide to a times, and you flip the second one. So the sum of that series, if I added up all of those numbers on and on and on in the infinite number of terms in that sequence, if I added them all together, I would get 200. All right, so I've just applied that formula there. Okay, let's have a look at the next one. We've got, if you want to try and pause the video now and try this example by yourself and then check it with my answer after, you're more than welcome to do that. So we have got 27 on 8, 9 on 4, 3 on 2, etc. Okay, so we have the sum of the first infinite terms is going to be T1, which is 27 on 8, divided by 1 minus the common ratio of r. So we need to find out what that r is, and it is going to be, remember, if we're not sure, we can just find the next term and divide it by the previous term. So I might do that off to the side here. Let's do r is going to be equal to 9 on 4 divided by 27 on 8, for example. So I picked the second term divided by the first term. And we can, remember, we keep the first one times and then flip the second one. And we look to cross simplify, so that's 2 and 1 and 1 and 3. So I've got 2/3 there as my common ratio r. If I wanted to just double check, I could now look at the third term, 3 on 2, and divide it by the second term, 9 on 4. And I would be keep, change, flipping again. And I've got 2/3 again. So I'm pretty happy there that my common ratio is 2/3. So I'm ready to substitute that into my formula. So it's going to be 1 minus 2/3 on the denominator. And when I go to solve that, it's going to be 27 on 8 divided by 1 minus 2/3, which is just going to be 1/3. All right, and we're going to keep change flip for one more time. And we get times by 3 over 1, and 27 times 3 should be 81 on 8, and there's no way to simplify that fraction down. So the sum of that infinite geometric series would be equal to 81 over 8. Okay, so really what we just need to understand is how to apply that formula and make sure that we can do that quick test of checking that our series is actually convergent, so we can use the formula. I'm going to do one more example in this video, and then I'm going to make a short second video for a CF style question that you might be interested in looking at as well. Okay, let's have a quick look. So write 0.7 recurring as a rational number. We know that a rational number is in the form P over Q, or it just means that it could be written as a fraction. And we know that this one here, 0.7, that's 0.7777 recurring. All right, so what's actually happening there is we have got 0.7 plus 0.07 plus 0.007. So we've got 7/10. I'm going to write these as fractions because I think I like fractions a bit more. So we've got 7/10 plus 700 plus 7,000, and that is going on forever. So what do we actually have here? We have an infinite geometric series. So let's have a look at what we know about this series. We know that T1 is 7 over 10, and we know that R is going to be the ratio between the next term and the previous term. So what we're multiplying by each time is 1 over 10. So to get from 7/10 to 7/100, we just need to multiply by 1 over 10, and so on. Okay, now we're ready to substitute that straight into our formula. So the sum of the infinite geometric, the infinite number of terms is going to be T1, 7 over 10, divided by 1 minus 1 over 10, which is going to be 7 over 10 divided by 9 over 10. Okay, and then we can keep change flip. So 7/10 times 10/9 is going to be equal to 7 over 9. So that 0.7 recurring can actually just be written as a fraction 7 over 9. Okay, that's it for me for these SF style questions. I will do one CF question too to help you, but if you have any questions, make sure you just reach out to your teacher.